S. Chand presents Educational Video Lectures as per the new UGC curriculum. Difficult concepts made easy. Study anywhere, anytime.
The most difficult task of a manager is to allocate the tasks or jobs to the worker. So in this video, we will be learning about how to allocate the different tasks to different set of people. The method that we'll be learning here is assignment problem.
If you want to study this topic in detail, refer to these books from S. Chand Publishing and Vikas Publishing House. Link is provided in the description box.
Welcome to S. Chand Academy, and I am Anmol Bhatia, and we'll be doing the course Business Mathematics, and in that we'll be learning an application of linear programming problem, which is assignment problem. So what is an assignment problem? Assignment problem basically seeks to minimize the total cost of assignments of M workers to M jobs. Let's say the government wants to construct the roads, and the government wants to give that contract to different third party contractors, and the government wishes to complete that task in a minimum period of time with minimum cost. So what happens, the government may allocate one particular road construction task to one contractor. Rather than giving all the jobs to a single contractor, the government may give that task to a single contractor. A single contractor is given a single road construction work, then another contractor will be given another road construction work. But whom to give that particular job? It depends upon the quotations that we received from the different vendors, and the managers need to do something at the back end to allocate those particular tasks to different set of contractors. So we'll be learning that particular thing, and that particular aspect is basically an application of linear programming problems. That is an advanced version of a linear programming problem. So here what will happen, we will look for certain solutions that generally the people follows or generally the people look for. Let's say we'll have this particular situation that there are 3 air conditioners that are to be installed in a same week by 3 different companies, and we got bids for each jobs from each company, and we want to allocate which company is to be given which type of building so that the ACs are to be installed. So we have made a particular table for that particular bid. Let's say there is a company A, B and C. So 3 companies are there, and they are giving their bids for all these 3 AC installation tasks. Let's say if contractor A installs that AC in building 1, that person quoted 53 monetary units, maybe lakhs or dollars or something. So we have taken this 53 monetary units, and for the next building he has quoted 96, for the next building he has quoted 37. Similarly for B has quoted 47, and B has quoted for the second building as 87, and for the third building as 41. So we have tabulated it, and what we want to do, we want to allocate that task to one task to one person. That would be a crux of this assignment problem. So we'll look for certain naive solutions in which the company may look for certain or different permutations and combinations. So there would be 6 different combinations for allocating that task, and let's say the company chooses like this so as to have a total cost. Let's say a company at random has given the first task to A, and the second task to B, and the third task to C person. So we would look for the total cost, and the total cost here would come after summing up all these values. So we'll get a value of 176. For the second sake, let's say the company chooses in this manner that the first task is to be given to the first person, the second person gets a third task, and the third person gets the second task. For this, the company is having a value of total cost value as 186. And for the third case, if it is this particular probability, the company is getting the cost as 179. In a similar manner, if the company chooses as A task to the third, B task to first, and C task is given to the second, the company would get a total cost value as 176 by summing all these values up. So 176 we got previously also, 176 we got in this case also. Then for the fifth guess, it would be like this, because the company has changed the particular order and they got the total cost value as 197. And for the third or for the last guess, the company has chosen like this and the guess is having 184. So overall, if we go with the guessing method, we got minimum solution or the minimum cost value in these two cases. So we got a value of 176 in the first case and we got this value in this fourth case also. That means either we can give the tasks to these persons like this or like this, that hardly makes any difference to the company. But this is only for a specific number of tasks. Let's say only 3 tasks are there and you have chosen certain permutations and combinations. But let's say if the task is very complex and you have n number of jobs and you have n number of workers and you are dealing with those particular aspects, then going with this hit and trials and going with all these guessing methods would not serve your purpose. So our objective is to have a clarity that we want to minimize the total cost after allocation of all these tasks to different workers. So for that particular aspect, we have got a particular method which is generally at the back end of majority of the aspects which require getting the quotations and allocating that particular job to different types of contractors. And that particular algorithm is called as the Hungarian algorithm. The Hungarian algorithm says that we have to go with the row minimization part and the column minimization part. What does it mean? We'll look at a particular example. So the first step is to have the minimum row minimization and the second step is the column minimization. The resulting matrix that would be there, that would be a non-negative matrix, and then we'll try to allocate the jobs by a specific procedure that we'll be learning through the help of the example. Now we'll look for an example which would be based on a specific methodology, and we will not be guessing any aspect so that the total cost becomes minimum. Let's say we have these 3 persons that wants the job and we have these 3 jobs, first, second and the third, and we want to allocate the task to different persons and our objective is to minimize the total cost. So the total cost should be minimum, that means after allocation the company should be at a minimum cost. So for that we have to go with the specific procedure and that procedure is minimization. Initially we have to go with the row minimization and then the column minimization. So we have formed a particular matrix and here in that particular situation we have to go with row minimization. What does row minimization means? We have to look for the minimum element in the first row. So in the first row we have the minimum element as 80. So we need to subtract 80 from the first row. So 80 is to be subtracted. That means we'll get 120 minus 80, 100 minus 80 and 80 minus 80. We'll get this value. Then the next row will have a minimum number which is 80, 90 and 110. So we have to subtract this 80 from all the elements. So 80 minus 80 would be 0, 90 minus 80, 110 minus 80. And from the next set we have the minimum number which is 110. So we need to subtract 110 from all these elements. So 110 minus 110 is 0, 140 minus 110, 120 minus 110 is 10. Then comes the case of the column minimization. What is column minimization? We have to go with the particular column. So in the first column we have zeros. So we need to subtract 0 from these columns. So we'll get the same elements because 0 is to be subtracted. Then you can see that 20, 10 and 30 are the numbers. So we need to look for the minimum. So 10 is the minimum. So we need to subtract 10 from all the numbers. We'll get 10, 0 and 20. and in the next set we have got 0, 30 and 10. So we need to subtract 0 from the third column. So we'll get 0, 30 and 10 because 0 is that minimum number. So that means we got a reduced matrix which is like this. So in the steps, if I repeat those steps, the first step is the row minimization and then the second is the column minimization. After performing the row minimization and the column minimization, we'll get a matrix, and that matrix should be a non-negative matrix. That means the elements that we'll get here should be non-negative. Now the only thing left is to allocate those tasks to that particular worker or the contractor. So we have a specific set of procedure in which we move from top to bottom and maybe we move from left to right. So firstly we have to move from top to bottom and then we have to move from left to right. So here we have to look for the first row in which there is a single 0. There should be a single 0. Where there is a single 0, we have to allocate that particular 0. That means that task is allocated or that 0 is allocated. If that particular column is having any other 0, we need to cross it up. So this do not have any 0, so we will not cross any 0 which is there in that particular column. In the next row, we have 2 zeros, so we need to skip this particular row for allocations because we are not sure that which 0 is to be allocated. Then in the third row, we have this 0. So here in the third row, we have only the single 0, so we need to allocate this 0 and cross the corresponding elements of that particular column. So we have allocated this 0 and we have to cross the other zeros which are there in that particular column. So we have crossed it. Now top to bottom procedure is over. Then we'll move from left to right. Now in the left to right aspect, the first column is already allocated. The second column has a single 0, so we need to allocate that particular 0 and cross the remaining ones. In the third, we have already the allocation. So that means we want to allocate 3 tasks to 3 persons, and here you have 3 allocations. So this completes your allocations. That indicates that A, B and C, this indicates first, second and third. So here we can easily write that A will get this third task, B will get the second task and C will get the first task. And what would be the value of the cost associated? The cost associated value would be checked from the initial table that you have. So initial table was this table that was given in the problem. So A task was given to this third, A person will get the third task. That means A is connected to 3. So we'll write here 80. Then B is connected to the second task. That means we'll write here 90. And C is connected to the first. So that means we'll write here 110. When we total it up, we'll get the total cost, and that total cost will be minimum, no doubt. So that total cost will be minimum, we'll get a number, and that total cost will be minimum. So we need not to go with hit and trials, or we need not to go with certain guessing to allocate that task to that particular person. So in that particular aspect, we have to follow this methodology, and this methodology is called as a Hungarian problem. Now we'll try to look at another question, and that question is also an application based question in which let's say you have your application, which is let's say an application of Uber or Ola, in which you have entered, you have to go to a specific location, and in that particular application you enter that particular location. Then only one cab is allocated to you within fraction of some minutes. So what happens, only one cab is allocated to you. That means one job is allocated to one person. So that means one cab is allocated to one particular person. That means in the backend there would be an algorithm in the application, and that algorithm would be this assignment problem or the Hungarian algorithm that would be working in the backend of that particular application. Now, how does that app works, or how does that algorithm works? We'll be looking at the same procedure with the help of this example. Let's say there is a cab company, and that cab company get 5 calls from 5 customers simultaneously. in the similar grounds that you book that particular cab from Ola or Uber. So let's say that cab is having these 5 customers. These 5 are the cabs and 5 are the customers. So we have 5 customers, 5 cabs. And the distance associated is given. The 5 cabs are out in the field at various distances from each customer. Let's say when you open that application, you will get n number of cabs flashing on your GPS application of that particular application. So what happens, a cab is at a distance of, let's say, 10 units from the first customer, a cab is at a distance of 5 units from the second customer, a cab is at a distance of 13 units from the third customer, and similarly for the fourth customer, similarly for the fifth customer. So we have 5 customers and the distance associated can be tracked through that GPS. Similarly for the B, similarly for the C, similarly for D or E. Now what we want, we have a particular customer should get one particular cab. We want to look for that particular solution. And that particular solution, if it is related to the company should get that particular allocations in minimum cost. That means those 5 customers will get that 5 cabs in the total cost, which is minimum. So we want to go with Hungarian algorithm and we want to allocate those cabs to the customers. So we'll follow the same procedure or the same protocol. We'll create a matrix. So this is the matrix that we have created, which is A, B, C, D and E, and we have 5 customers, 1, 2, 3, 4 and 5. Now the procedure says that we have to minimize or we have to reduce the matrix by going with row minimization and the column minimization aspect. So row minimization says that we have to subtract the minimum of the numbers which are there in the first row, and we have to subtract that minimum number from all the elements. So 5 is the minimum number and we need to subtract 5 from all the elements. So 10 minus 5 will be 5, 5 minus 5 will be 0, 13 minus 5 is 8, 15 minus 5 is 10, 11 minus 5 is 11, 16 minus 5 is 11. Similar grounds we have to subtract for the case of the second row, for the third row, fourth and fifth row. And in the similar fashion, we have to go with the column minimization. Here in the first column, you have 0 already. So 0 is to be subtracted from all the elements, that remains unchanged. In the second, you already have a 0. In the third, you already have 0. Fourth, fifth, you already have 0. So there will be no change between the row minimization and the column minimization aspects. So what is to be done with this reduced matrix? We'll try to allocate that particular assignments with the help of that Hungarian problem. So let's have a look at the solution. As I have told you that we have to move from top to bottom and we need to go with left to right scenarios. So when we move from top to bottom, we'll have a single 0 which is there. So we'll allocate that single 0. So this first 0 is allocated, then we'll look for the column. If that particular column is having a 0, we need to cross it up. Then in the second row, we have a single 0. So we have to allocate that particular 0, and if it is there in the particular column, any other 0, we need to cross it up. So this 0 is to be crossed. In the third row, we have 3 zeros. So what we need to look for, we need to look for the allocations, but we would not be sure that which 0 is to be allocated because there are 3 different zeros. So we need to skip this row. Then coming to the fourth row has 0 and this is already crossed. So we are also not sure in this particular situation because this had 2 zeros. So we intentionally would skip this particular row. Then in the next row, we'll have a single 0. So we need to allocate this 0 and we need to cross the remaining elements. So these remaining elements of the column needs to be crossed. So what we have done, we have moved from top to bottom and allocated the zeros. Now we will move from left to right and we will allocate that particular 0. So here you can see that first 0 is already allocated, the second 0 is already allocated in the second column. In the third column we have a single 0, so that needs an allocation. And if in that particular allocation, in that particular row, if there is any other 0, we need to cross it. In the fourth, we have one allocation, and in the fifth, we don't have any allocations, or we don't have any zero left. You may notice here that we want to allocate 5 cabs to 5 customers. But here, how many allocations? 1, 2, 3, 4. We have only 4 allocations. That means we have to do something in order to allocate that particular cab to the customer. So here, this method got stuck, and we have to perform iterations that we did like we did in the other linear programming problem aspects. So for that particular situation, there is another set of method that we would be looking. So we stop here for a short break. After coming back from the break, we will look at that particular method which would try to give us a particular solution for iterations in case of assignment problem.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on UGC curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting within the comfort of your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. Before going to the break, we have learnt Hungarian algorithm, in which we have seen the case how to allocate the particular job to the particular worker or particular contractor. But we got stuck in a particular situation in which we have not got all the allocations completed. What we got in that previous case, that we want to allocate 5 jobs to the 5 customers or 5 contractors or 5 workers, but we were unable to do that with the help of that Hungarian algorithm. So I have told you that we will be looking at a particular method in which we will be allocating it through that add-on. So what is that add-on? We will look for that particular solution. So this procedure we will be reading in a few minutes, but before that, let's come to that particular problem that we were doing. So I have told you that we had the case of 5 cabs and we had the case of 5 customers, and we were trying to allocate that particular cab to the customer. So here we noticed that we have allocated only 4 cabs, but the 5th cab is still pending. So what we have to do, we have to follow a particular procedure in which we will try to cover all the zeros with a line, and how to do that, it has a particular procedure. So what is this procedure? We will need to tick the unassigned row. This is the first procedure or the first step, and if that ticked row has a 0, we need to tick the corresponding column. What is this step saying? Let's have a look. So the first step is to look for an unassigned row and tick it up. So here the unassigned row is this 4th row, so we need to tick that unassigned row. Now, if in that unassigned row any 0 is there, if this unassigned row is having any 0, so here there is 0, here there is 0. So we need to tick the corresponding column. So we need to look for or tick an unassigned row. If that unassigned row has a 0, we need to tick that particular column. These were the 2 steps. Now, if that ticked column has an assignment, tick the corresponding row. So what does this step says? If this ticked column is having any assignment. So this ticked column is having this allocation or an assignment, so we need to tick the corresponding row. Here also, if that ticked column is having an assignment, this is an assignment, so we need to tick the corresponding row. Repeat the steps till no more ticking is possible. The next step says, so this is a row, we need to look for any other 0 which is unticked. So look for any 0 which is there. So this is 0, this is already ticked. That means the ticking process is complete. Now what to do with all these ticks? Draw lines through the unticked rows and ticked columns. So we have to place lines through the unticked rows and the ticked columns. So we have to place a line through the unticked row. So these 2 were the unticked rows and there were 2 ticked columns. So this was a ticked column, this was having a ticked column, and this was having a ticked column. So we have to draw lines over the unticked rows and the ticked columns. Now, what we need to look for, we need to look for the smallest number, not having any line passing through it is taken as theta. So we need to look for the remaining numbers which are not covered. So this is a non-covered number, this is a non-covered number, this is also a non-covered number. So we need to look for the minimum number from all these non-covered elements. So minimum number, you can see that this is the minimum number. And we'll keep that minimum number as theta. We'll name this minimum number as theta. And how do we use this theta? Where these two lines are matching, we will add theta. And where there is no line, we will subtract theta. What does it mean? Here you can see that two lines are meeting, and it is meeting on 5. So we will add theta to this 5 number. So 5 plus 2 would be the case. So 5 plus 2 would be 7. So in the new iteration, new set of iteration, you will write 7 here. Here there is a single line on this element, so you will do nothing. Here there is a single line, you will do nothing. Here on 10, you are getting two different lines. So you will add theta here. So 2 is to be added here. Then you will do nothing here. The 0 is having a single line, you have to do nothing. Then 6 is having no line. So I have written when there is no line, you need to subtract theta. So 6 minus 2 would be 4. 15 minus 2 would be 13. And 10 minus nothing, that means 10 would remain 10. 3 minus 2 will be 1. So in this fashion, you will do what? You will iterate it, or you will modify the solution, modify these elements into next or the new set of elements. So what we have done the sticking process, and I have told you that we found theta. Where two lines are matching, we have added that theta, and where there is no line, we have to subtract theta. So after doing it, the matrix is converted into a new set of matrix, that is 5 plus 2, that is 7, 0 remains 0, and in the similar manner, I have formed a new matrix. Now this new matrix would give me a particular solution for the allocation. That means I need to carry out the same Hungarian method, that is from top to bottom allocations and then the left to right allocations. So how to do that? Same procedure. When we move from top to bottom, we have to look for zeros. So here you can see that there is a single 0, so we need to allocate that particular 0. And if that particular allocation is done, so we'll look for the corresponding column. If that corresponding column is having any other 0, we need to cross it up. So it does not have any other 0, so we need not to cross it up. Then in the second row, we have to look for any 0. So this is having a 0 and single 0 is there, so we need to allocate that single 0. And if that particular column corresponding to this allocation is having any other 0, we need to cross it up. Why we are crossing it up? Because we want to allocate one task to one person only. In the third stage, we are having these two zeros, so we need to skip this particular row. In the fourth, we are having two other zeros, so we need to skip this fourth row also. The fifth row is having a single 0, so we need to allocate this single 0. If this is allocated, we need to cross the other elements of the corresponding column. Now top to bottom part is over, then we'll move from left to right. So in the first column, you already have an allocation. In the second, you have an allocation. In the third, you have two different zeros, so we need to skip it up. The fourth is already allocated. Fifth is having 1 0. So you need to allocate this 0 and cross the remaining elements of the corresponding column. So top to bottom is done, left to right is done. Now you can see that there is another 0. So you need to follow the same step, that is top to bottom and left to right. So we'll move top to bottom again. So first row is allocated, second row is allocated, third is also allocated, and in the fourth you are having 1 0 which is left unallocated. So we'll allocate it and look for any other 0 in the corresponding column. So because we are moving from top to bottom, so we'll look for a particular column. So any other column having 0 is not there. So this fifth one is already allocated. So what you have done, you have done all the allocations now. So how many allocations you can count? 1, 2, 3, 4 and 5. So In the earlier stage, you were having 4 allocations and you have done that ticking process, which is the iteration process, and you have converted that particular matrix into a new set of matrix just to allocate those elements together. So this you have done, and after doing it, what you got this, you have got this question, and the result that we may get is A cab is given to the second customer. So this is the first one, this is second, this is third, this is fourth, and this one is fifth. So what we can say that A cab is allocated to the second customer, B cab is allocated to the first customer, C cab is allocated to whom? To the fifth customer, and D cab is allocated to the third customer, and E cab is allocated to the fourth customer. And this is the back-end process. Now you have to look for the distances. So as I have told you that A cab is allocated to the second customer. So A to the second customer is having a value of 5. So this is having a distance of 5. That means the shortest distance is there. And B cab is allocated to the first customer. So B cab is allocated to the first customer. That means the shortest distance part is being allocated there. So this is 3, and the C cab is given to the fifth customer. So C cab is given to the fifth customer. So here the distances were many, like C cab was connected to the third customer also, fourth also, fifth also, and there were the distance, they were having the same distances, and we have to choose from all these distances. Then D cab was connected to the third customer. D cab is connected to the third customer. Here the minimum number was 7 also, but we have chosen the next minimum. And the E cab was given to the fourth customer. E cab was given to the fourth customer. That means this is the case. So this is the fourth customer, and this was 9. So you can see that all these customers are getting the cabs in minimum possible time, because the distances are minimum or less distances which are there in every particular situation. So we got a particular algorithm here in the second stage. So with this we come to the end of the video, in which we have learned the procedure of the assignment problem. The first case that we have seen was a general allocation, and in the second case, when we are not able to allocate as per our requirement, we have to go with the ticking procedure. Ticking procedure is basically the iteration. After performing the iteration, we will get the particular allocations as per our requirement. Thank you.
If you want to study this topic in detail, refer to these books from S. Chand Publishing and Vikas Publishing House. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.